Our next calling point is going to be partitioning our disk, breaking it into smaller, more manageable blocks. There are a couple of tools that we can take a look at. Fdisk is our more traditional tool that's available in many different operating systems and have been around for a long time. It's menu-driven, but it can't be scripted. Whereas its more modern counterpart, Parted, can also be run interactively, but it is allowing scripting that makes it a firm favourite. The partition table type is known as a label. We have the traditional MS-DOS, yes, MS-DOS partition table. Believe me, that is correct. But this allows for 4 primary partitions with a maximum size of 2 terabytes each. And it's probably that 2 terabyte limit that is causing some real limitations today. When we look at its modern counterpart, the GPT or GUID partition table, the GUID partition table allows for a maximum of 128 partitions per disk, with a maximum size of potentially 32 exabyte. However, the number of partitions is really going to be controlled by your disk driver or the module you're using to access the disk, and the partition size is going to be limited by the file system that you are implementing. When we look at using Parted, we need to elevate our privileges and, of course, look at the correct device. Here we're looking at our loop device, but make sure you use the correct number that represents your loop device. We can combine many commands together. Here we're using both mclabel and mcpart. We have to have a partition label before we create our partitions. The label is where we are storing the partitions. For our partition, we're creating a primary partition, and we are setting it up to use 25% of the disk. As we continue, we can create a second partition. Here we're starting then at 25% and finishing at 50%. So we're just using 2 partitions on our disk out of a maximum of 4 and only using half of the size. We can also print the partition table, and we can go through and list our block devices. Parted is writing the information back immediately, so we don't have to worry about saving it, so the operating system should be aware. However, if the disk was active, maybe the operating system didn't get updated, so we can use part probe. Here we're looking at our SDA device to update the operating system from the loaded partition table. Now, the best thing that we can do is to dive out now to take a look at this at our command line. So this is our party palace and where the learning begins. We can use Parted interactively. So if I go through and use sudo parted /dev/loop16, making sure that you're working with your correct loop device, I can type help to get a list of commands, but I can try and print out the partition table. Now, because I don't have a label as yet, we don't have a partition table, so we're getting a partition table unknown. We can create the label, so mclabel MS-DOS. Now, of course, I can print it out, but as yet I don't have any partitions. So let me just quit out of this. I can use it interactively, but we might prefer to use it directly from the command line and script it. Now I'm going to begin by just clearing any of the work that I've already done. We've got a command called wipefs, and we can use this to clear file system header information, or as we're doing here, we can wipe everything, including partition information. Now again, be very careful. We're running as root, so make sure you're pointing through to the correct loop device. But we have now cleared everything, so we can start all over again. And we're going to see now how I can do everything from the command line. So sudo parted for our correct device. Again, double check you are working on the correct device. We can add our label, and we want that to be MS-DOS. We can create our first partition, and we can say that we want this to be a primary partition. and we're going to be starting at the start of the disk, or as close to the start as we can get, and we can go through 25% of the disk. So we'll just take a quarter of the space. But look, we can go and create a second partition now. So MUCPart primary, continuing from 25% until we get to 50% of the disk. And not only this, we can now issue our print command so we can print our newly created partition table. Now, all of this is dynamically working both with the operating system as well as with the partition table that we are seeing. So the operating system will be aware of this. I don't have to worry about saving my changes back to the disk. We can show how aware the operating system is by running our lsblock command. We'll drill down just to our loop devices, and now we can see that we have two partitions, partition 1 and partition 2 on loop 16. So all is good. However, if we weren't seeing those partitions, and maybe because we've added partitions into an active disk, then we could force the operating system to become aware of that, and that's where our command part probe comes in. Again, we have to execute as the root user, so elevating with the sudo command. And with a little bit of fancy footwork, we can put in our part probe command and tell it, and I'm going to say, take a look at /dev/loop16. As our operating system is up to date, this isn't going to affect anything. However, if you weren't seeing the partitions with lsblock, this is updating the operating system.